So we're asked to create an argument or a proof showing that the cosine of alpha minus beta is equal to this following formula over here. To start out the proof, what I'm going to do is I'm going to draw out a unit circle, and I'm going to draw two angles. I'm going to draw angle alpha and angle beta. So let's draw angle alpha in orange, like this. So this guy is angle alpha. Now, it's this point right here, its ordered pair by definition is the cosine of the angle for its x value. Since it's on, I said it but I didn't write it down. It's the unit circle. So its x value is cosine alpha and its y value is sine alpha. Then what we're going to do is we're going to draw another angle in here. So beta. Do that in green. So this little angle right here is beta. And this point, its x value is the cosine of beta, and its y value is the sine of beta. Now this angle in between, we'll draw it here in purple. This angle in between right here, that is alpha minus beta. So this angular measurement right here is alpha minus beta. Okay, so let's draw a little arrow up into there. Now let's draw another circle. So another unit circle. And what I'm going to do is I'm going to draw this purple angle in standard position. So it's going to look like this. So what I've done is I've taken this guy and I've rotated back so that this edge right here falls on this axis. So I've essentially rotated this angle down, which is this. So this angle right here is the angle alpha minus beta. So this point right here, its x value is the cosine of the angle. Well, the angle is alpha minus beta. And its y value is the sine of the angle. So there it is. This point right here, since it falls on the positive x-axis, is 1, 0. So we're going to use that point as well. Now, our proof is going to rely on the following. This distance, let me draw it out here for you. This length right here is the same as this length right here. So this length, because we've just rotated down to put it in standard position, is obviously the same as this length right here. So we're going to use that. So let's talk about those lengths. We'll call it distance, and we'll use a distance formula. The distance between 2 points is the sum of the difference between the x values squared and the difference between the y values squared. Then you take the square root of that. So if you remember your distance formula, it's going to be the difference in my x values squared plus the difference, whoops, I need an extra parenthesis. Let's use brackets here. Oh, that was no good. So that guy squared plus, now the difference, excuse me, in the y values. So let's go ahead and reduce this. Well, actually, hang on. So let's set this equal to the following. Over on this side, the difference, the distance, is the difference between my x values squared oops, we gotta put our 1 in there, plus the difference between our y values squared. Sine alpha minus beta minus 0. Now if we square both sides, we'll get the following. And we can square both sides here, and here's why. This guy over here is positive. This guy over here has got to be positive because we're taking a square root as a distance. So when we square both sides of two positives, they're still going to be equal to one another. So I get the following. From here on out, the rest of this problem is just algebra. But it may be something that you would have had some difficulty maybe doing the algebra on your own. You might have goofed something up, whatever it is. Okay, so this is just the algebra. So here, I'm going to do the left side here in green. Okay, so it's going to be in green. So cosine alpha minus cosine beta is the following. It is cosine alpha squared minus 2 cosine alpha cosine beta plus cosine beta squared. You gotta FOIL this guy. Now let's do this guy over here. So that's going to be sine squared alpha minus 2 sine alpha sine beta plus sine squared beta, like that. That's just the left side. We haven't even touched the right side yet. This looks like a big mess, and it is. So let's reduce some stuff here. We have the following identity. So this is our Pythagorean identity. And I'll write it up here in blue. Sine squared of any angle plus the cosine squared of any angle is 1. Oops, that didn't write very well. So let's go like is equal to 1. So let's talk about things that cancel out here. Well, cosine squared alpha plus sine squared alpha, so these two guys give me 1. Cosine squared beta, sine squared beta, also give me 1. And I'm just going to write everything else down here. Like that. So when I combine these two terms, let's scroll down just a little bit. When I combine these two terms, I get 2. So this is my new left side. Now let's play around with the right side. So I'm going to do that in yellow. So this guy squared is cosine squared alpha minus beta minus 2 cosine alpha minus beta plus 1. This guy squared is easy because it's just this first guy squared. So plus sine squared alpha minus beta. Again, notice over here on this side, cosine squared alpha minus beta plus sine squared alpha minus beta is equal to 1. So I got 1 plus 1 minus 2 cosine alpha minus beta. And that's equal to this guy over here. Let's write them all in the same color now. Like that. These two guys put together to give me 2. So I'm going to divide everything by 2. Actually, before I do that, I'm just going to, notice I have a positive 2 and a positive 2, so let's subtract 2 from both sides. If I do it, these two guys are gone. Now, what do I have left? And you can tell we're almost done. So if we just divide everything by negative 2, let's write plus. Right, because if I divide this by negative 2, it becomes positive. This by negative 2, it becomes positive. And there it is. That's your formula. So we can easily just write this guy over on this side and put these two guys over on the other side. It's the same thing.